Question 22. Three photodiodes D1, D2 and D3 are made of semiconductors having band gaps of 2.5 electron volts, 2 and 3 electron volts respectively. Which of them will not be able to detect light of wavelength 600 nanometers? And the B part is why photodiodes are required to operate in reverse bias. So we know that energy is basically the frequency and is calculated by the speed of light divided by the wavelength. So here the speed of light is 3 into 10 raised to the power 8 meter per second, and wavelength we have been given 600 nanometers in the question. Putting these values in the formula, we get 6.63 into 10 raised to the power minus 34 into 3 raised to the power 3 into 10 raised to the power 8 upon 600 into 10 raised to the power minus 9 joule. The answer comes out to be 19.89 joules, and to convert it into electron volts we divided by 9.6, so we get 2.08 electron volts. Now we need to detect that diode which will not be able to detect light of wavelength 600 nanometers. So band gap for D1 is 2.5 electron volts, bandwidth for D2 is 2 electron volts, and bandwidth for D3 is 3 electron volts. Now D1 and D3 will be able to detect light of wavelength 600 nanometers because their band gap is greater than 2.8 electron volts. So only D2 will not be able to detect light of wavelength 600 nanometers because it has a bandwidth of 2, which is less than 2.08 electron volts. Now the second part was that why are photodiodes required to operate in reverse bias? So this is pretty much easy because in reverse bias we can easily observe the change in current with change in light intensity.